Okay. So OPEA, what does it stand for? It stands for the Open Platform for Enterprise AI, and that's what we're going to talk about today. So I'll give you an introduction and how you could get involved. And I'm super excited to be here today. And a little bit about myself. I'm a cloud native architect focused on AI, confidential compute, security everywhere, and performance. I've been engaged in open source for over a decade, and it began with my work on Intel server platforms and realizing they were only 30% utilized. So it had to be a shared resource. And, that was like around the time of the birth of the cloud. And lo and behold, we're here. And the cloud has enabled a lot of this AI because when I started working on my PhD nearly 25 years ago, nearly 30 years ago, it was a very, very dark winter of AI, you should say. Computing was expensive, storage was expensive, and you didn't have cameras everywhere to create so much data and so on and so forth. So today we're in the high noon of AI. And over my career, I worked on autonomous driving, healthcare, remote monitoring and management, and stuff like that. So, frequent speaker, and my AI machine learning PhD is ancient and it's very different from today. So, I'm a learner all over again. With that, we're going to talk about what are Gen AI adoption challenges, a closer look at OPEA, and how you can get involved. So the typical Gen AI pipeline, I mean, you've had a few earlier talks today about foundation models. Those take a lot of time to build. They're very expensive and they're also points in time. A foundation model might have been born in 2022 or 2023. So the state of the union of whatever we know in our collective intelligence is fixed in 2022 or 2023. So if you were to ask it a question about what's happening in today's US election for a president, it'll say who are the candidates. It would have said to you Biden and Trump. And it's a very different reality today, at least in the last 8, 9 weeks, where the candidates have changed and it's a close race. So to handle the fact that things are changing and you want answers that are more relevant to your domain or answers that are more current, you get into this whole retrieval augmented generative AI. And that's what this talk really is starting with OPS first focus area being RAG, this retrieval augmented generative AI. So the typical RAG pipeline has an ingestion phase, whatever documents, whether it's news stories from New York Times or BBC or whatever, or medical journals or law literature, whatever, that's your domain specific data. So there's this process where you acquire it. You basically ingest it and you build vectors out of it. And that's this embedding model. Why vectors? So you can retrieve them quickly, because otherwise there's so much out there. That's how all this library retrieval systems came up, right? All those ISBN codes and stuff like that. So once you start embedding stuff, you've built your vector database, and essentially it becomes like your reference section. You want to answer a question, you find the answer, and you say, I got it from this journal article or from this published study or whatever. And when you retrieve stuff, something else that's very important is you might have retrieved like 100 pieces of literature or whatever that's relevant, or maybe 1,000. Just like, when you do your Google search, you have pages and pages of them, like maybe 20 pages. What are the top ones? So that's where this retrieval ranking comes in. And it's also a place where you might specify, like, I want information that's more current or more, maybe in a particular medical journal or a more recent case that the Supreme Court has cited or whatever. So you can have additional characteristics that are going to be used for your ranking. And then you take whatever you've retrieved, you take your original prompt, you pass that all into your large language model. So this is really the engineering aspects of it, the whole workflow of it, okay? And eventually, before you send any response to your user, you want to confirm that there's no bias, that there is no bad language, that is not repetitive, because sometimes it can get repetitive, and we all do it. So you want to clean up stuff, and you also want to make sure it's nothing lethal bad, profane, annoying, that sort of stuff. So that's where you use guardrails and then you give a response back. But with anything in life, we have a feedback loop. So it's also nice if the end user says, yeah, it was useful for me, just like we give responses back on, your favorite shopping site and say, yeah, the recommendations you gave me were good, or the movie you showed me was good, and so on and so forth. So there's a feedback loop, and we haven't yet addressed that piece in OPEA. Okay. So this is your typical RAG pipeline. Great. Now let's just take a brief look at what Gartner and other industry publications say about this whole Gen AI wave. Okay. So they say the top challenges are technical complexity. You saw that pipeline was not trivial, was pretty significant. Um, Let me see if I can move this guy somewhere down. Okay. So it's technical complexity. You saw guardrails, you saw um, embedding models, you saw large language models or large vision models, depending on whatever use case you have. You had the whole document set, and document sets can be like, 100 documents, they can be 1,000, they can be 1 billion. So scale makes things more complex. How you handle it, a database that might handle 1,000 things might croak under, 1 billion records inside it, type of stuff. There's cost. Everybody and anybody might not be able to train these large language models. And that's why I'm so grateful that to sponsor and promote, like a democratic use of AI, that people are sharing these large language models and vision models and all. So those are the foundation models that are open sourced. Uh, so apart from the cost, there's also this talent scarcity, because somebody who's good in AI might not also have cloud chops, and those who have cloud chops might not have AI expertise. And I fall into that second category because that old PhD of mine is rusty and clunky and things like that. So typically, when things are complex, things are difficult to grok. This is where open ecosystems add value, and I've done this for so many years, and it's definitely a fact. When we first started creating this cloud software called OpenStack, at that sort of scale that people were looking at, not like 10 machines, not 100 machines, thousands of machines in different geos, and being able to share resources, scale them, schedule them, detect problems. And they brought up terms like pets versus cattle and things like that. For a Hindu, didn't make any sense. But the whole open stack thing is still in use today, and it brought expertise from so many different people, and like CERN, who uses it at super scale for all their collider kind of experiments, to banks today, hospitals, just name it. Okay. So we know that open ecosystems work. Linux is one proof point over there. It's served to teach people, you know legends of students to learn how to create an operating system, file system, um, scheduling, name it. So we have now an open ecosystem for AI, and in particular for generative AI. So the vision of this OPEA platform is to enable enterprises to develop and deploy Gen AI solutions powered by an open ecosystem that delivers on a few things: security, safety, scalability, cost, efficiency, and agility. Okay, so let's get into this. I'm pretty proud of our vision statement. So the project itself, we wanted to ensure it's totally open. So open governance. The Linux Foundation is a big proponent of this. It's been around for decades. It's the mother, father, everything for the Linux operating system. So we put our project under it. It's got a technical steering committee, and the representatives are pretty diverse. We have end user people like Comcast, the ones who show your videos, etc., your news. We have Fidelity from the finance sector. We have Justin Cormack from Docker. That was the whole beginning of this cloud native ecosystem, because even though we had Linux containers, it was really Docker that popularized the whole thing. We have Logan from Llama Index. So they're the folks that create the glue to combine all these, components that I mentioned and give you whole Gen AI pipelines. We have system integrators like Nathan from CDW, and then my own colleague Ding from Intel, who's an AI expert. So we also have end user communities, Artifactory, etc. from JFrog, and then we have from Fidelity Armor. Okay, so who else plays in this space and is very active in this space? It's Red Hat because they work closely with enterprises. You have your hospitals, you have your finance companies. They all don't want to say, okay, I have open source, let me just use it, because there's a cost associated, even with free open source, because you still have to update things, add features you need, maybe customize something else. So Red Hat plays a very integral role there. So that's our panel. But I'm super, super glad to also add that as an open source project, it also brings in different hardware vendors. So I'm very happy and excited to say that AMD is part of this open source project. I think we will get ARM later on, and we're making sure any solution of ours also works with NVIDIA GPUs because they're, like the top GPU providers. What else is significant in terms of this OPEA landscape? We have a home site, there's a link here. We have a calendar that advertises all our different work groups, be it evaluation, security, end user, documentation. Then the technical steering committee that I mentioned that captures people from different walks in this space. And the work groups themselves, like developer experience, end user, evaluation, then the community and research. So research hasn't yet taken off. So I'm super excited that you all are listening today. And I think several of you are from a research background. Security is also going to be very, very integral to us. So with that, yep, we have several partners, over 40 of them, from Hugging Face to, large system integrators in India like Wipro, etc. So with that, let's dive into the open source project itself. So we have a GitHub home, like all open source projects. I mean, that's a basic necessity. What are the different sub projects under the OPEA project? We have the Gen AI components or comps. So think of it as Lego blocks. We've all played with them as kids. So you have your yellow block, blue block, red block, etc., etc., and then they have different shapes too, not just the colors. So these components are the ones we'll use to create, whether it's your building or your ship or your palace or your garden or whatever. So the Gen AI comps used to create the Gen AI examples. And before we get into examples, let me tell you a little more about comps. Just like your different color blocks, for each kind of block, whether it's a wheel or a rectangle or a square, you might have multiple different options. So for large language models, you could have different frameworks to supply them, or, like inference frameworks. So there's your TGI, you have your VLLM. So those are the flavors of, language model servers. You have flavors of vector databases from Redis to Postgres to Milvus and so on and so forth. You have multiple different solution options for guardrails, for re-rankers, for embedders. And further, when you're talking your large language model or your embedding model or your re-rank model, you have different options even for the model you're going to use. And they can be things like 7 billion size parameter models, 500 billion size parameter models, or tiny little 2 billion and even smaller. Okay. So if you're using a very small model, you can even run a whole Gen AI pipeline on your laptop. And that's really super good for us to warm up and to also start experimenting on our own and feel like, this technology even I can play with and get our hands on and make a difference type of stuff. So then with the Gen AI examples, and this is kind of significant because we wanted to bring down the barriers for Gen AI adoption. So it's important to think of which problems people will typically want to solve, right? And then you can say, in the context of, baking a cake, what do I need type of thing. So the top example of ours that we've seen that everybody and anybody kind of is interested in is a chat Q&A kind of solution. So it could be you're going to an appliance store and then you want to order a refrigerator, but the minimum thing you have to start providing in terms of information is your family size, how often you eat in and out, and whether you cook or whether you're just opening cans of food or whatever, right? So your chat Q&A, just like that refrigerator example, has to comprehend how many documents you will have in your retrieval augmentation, how many concurrent users you'll have, what kind of complexity in terms of language model support you want, or maybe you want a fine tune model because you're looking at a small subspace of maybe medical literature in the radiology, subspecialty type of stuff. Now, the chat Q&A could have taken prompts that were text-based. It could take audio prompts. It could take visual prompts, like you can show it a picture of a plant and say, well, can you please tell me more about this plant, It could be things like summarization, because we're also at a cusp where we have too much information and we want to summarize it. Not everybody has time to read a 40-page document or a 400-page treatise. Then a very important thing is translation, and we've made such enormous strides in that. So you can take something that's in Spanish or even Hindi and say, can you please give me the English version of it? You don't even need today to create documentation in different languages with, genuine first-person human authors. You can use auto translation. And Google has said that they're getting like 25% of their code written by AI. So code generation, code translation, where you might have written code in Go and you want to translate it to Rust or something for more security. So now we've covered two sub projects in OPEA. And what is the other two? Apart from documentation, because that spans everything and it's self explanatory. So we have Gen AI Infra. And why do we call it Infra? Because these Gen AI solutions to work at scale, to handle enterprise use cases, they will have to run in a cloud somewhere, either on prem or some third party cloud type of thing. So here we handle things like scaling. And in the Kubernetes landscape, several of you might have already used Kubernetes. There are things like horizontal pod auto scaling. So what metrics do we collect? When do we trigger a new instance? And even if we create a new instance, does the work just get balanced across the two new instances? And there's several software solutions like TGI that has an internal queue. So the moment it's gone into that internal queue, even if you create another instance, it's not like the work is immediately getting split between the two instances. It takes a while for this internal queue to drain, but future instances get load balanced across the two separate TGI instances. And there's, of course, authorization and authentication. You have your Hugging Face kind of tokens, but in your own company or in your university, Malini might be authorized to look at certain classes of documents. In Intel, we call them red cover, orange cover, and so on and so forth. But another user might not be able to access them, or they might be accessing much more internal secret documents. So it's some level of your role in the company or your enterprise. And then there is service mesh. This is a technology that allows you to focus on your domain work and not have to deal with all the regular everyday aspects of any application, such as logging, audit trails, setting up mutual TLS so that all your traffic between your microservices are encrypted and so on and so forth. So with GenAI Infra inside OPEA, we are addressing not just the AI aspects that you see in these top two boxes, but the enterprise related aspects where you want to do scalability, confidentiality, security, and so on and so forth. Then, last but not least, with any AI pipeline, you have to do some kind of evaluation of the individual components, not just for their performance, but things if it's an embedder, what is its retrieval? Can I get the same level of retrieval and accuracy there, even if I use quantization? Because there's a cost to all this, right? Even if you use int 8, that's int 8 size. I mean, it's 4 bytes. But what if I could do it with, 4-bit quantization? Or what if I could just use maybe instead of 32 bits, 16 bits, and so on and so forth. So this is where we deal with things like performance and then cost from storage savings. Also a place where you say, what can I say about this model? Is it hallucinating left, right, and center? Is it toxic? Um, how is that response type of stuff? So whenever you're looking at somewhere like Hugging Face, they do give you such information, and some of this is just captured there. But in a pipeline, it's not just is A by itself good. Okay, so maybe if I had used 4-bit quantization or 8-bit quantization, but then I had used a better model or something else, I can maybe compromise and save somewhere else in that pipeline to still get a good solution. So when you're talking hallucination, toxicity, performance, accuracy, etc., in the context of a single Gen AI component, that's one way of looking at it. And then across the pipeline, and maybe it's cheaper to give additional resources in another part of the pipeline and still get a good answer in the end-to-end situation type of stuff. So this is our flagship example, the chat Q&A, and we have so many variants, after you made the basic chat Q&A. And let's just take a quick look at this. And we have demo links here, so I won't do the demo right now in our quick time slot. So we have an embedder, we have a chunker, we have the information extraction, but you're really going this way up. So you bring in all your documents. They could be Word, they could be PDFs, they could be URLs on the web somewhere. Then you pass it through and you chunk them. Chunk them can have lots of variations, right? I mean, they could be overlapping chunks, non-overlapping chunks, large chunks, chunks at the level of, a sentence, a paragraph. And then sometimes you can even use chunking with uh, hypertext, like markdown, was something, a title was something, a paragraph heading, because that contains a lot of semantic information for you. Then you stick it into a vector database, and these vector database flavors, like I mentioned, they can handle different amounts of scale. So there's some vector databases that do much better at scale, okay? Others are smaller, so it all depends on your needs. And then if you're working at an enterprise level, maybe you've kept everything, for your whole department or the computer science journals, etc., in a common repository, and they're vectorized in one common place, and everybody just points to that as an endpoint and retrieves what they want, versus having a copy on their own laptop type of stuff. Now, when you're asking a question, it just goes through the same thing. Use the same embedder, you go through the same vector database, you retrieve stuff, you re-rank them, then you send it to the LLM, and then out comes the response. And then this is at a lower level, in terms of the microservices over there. And those links are there. Okay, so how can one get involved? We had two recently concluded community events. One of them was called the October Hackathon. We had several issues that we had marked as good first issues. We had marked them as also OPEA hacks. And one of the things is you can create an open source project. There are the developer kinds who kind of debug issues, fix them, blah, blah, blah. They just kind of know their way around. But then what about those real total end users who just want to say, hey, there's this new Gen AI. I'm pretty savvy. I can do some things, but I can't debug everything. So what we wanted to do is make sure that we had recipes for them to launch them in any cloud. If they have a credit card, they have an Amazon account. I mean, they can go there, create a single VM or create a Kubernetes cluster, multiple of them, and then launch these workloads there. So now we have a getting started guide that has like, here's how you would do it in AWS on a single node, on a Kubernetes cluster. Here's how you do it in GCP or Oracle Cloud, and so on and so forth. Then we will, as part of this hackathon, requested folks, can you create Terraform scripts? Can you create Ansible scripts? Can you try this in an audio kind of scenario, and so on and so forth? So this hackathon just terminated. It was pretty good. We had quite some people asking us to use it, work with it. And I'm happy to say that we didn't know how many people would come. And then given that LLMs can be pretty expensive in the size of the instance you need to use, we even offered them Intel Cloud credits. We gave them a VM to play around with and launch these workloads. So we had like at least 12 people come. That means they were total novices without hardware of their own. So it was kind of exciting to get hands on with them. Then we had folks share their Gen AI nightmares, and we know, and it's a top discussion in many places. What about AI governance? It's no different from when we invented, nuclear fuel and nuclear bombs. And what is the responsibility of the scientists? What's the responsibility of the people to ensure that we use this new technology in a responsible way? So we were like, hey, have you seen any issues? So one issue with these Gen AI solutions is sometimes they're just looking for a pattern in the text in the document you've given them, and maybe it's not there. Maybe there's no clear single sentence like A did B to C or something like that. So this is where relational databases play big role. So if you were to use something like Neo4j or something, the graph databases help you. So that was one of the talks we shared in the nightmares, how it answers questions better. Then there was another one where they're creepy images, just the way you create them, and maybe you want to remove them because they creep out people. So when you're doing things like generative images, you might want to like clean out these sort of things to not offend people. So those were two of the talks we had. So with that, how can you get involved? Please try our getting started guide, on a cloud of your choice or on your own laptop using a smaller LLM. File issues, if there's inadequate, inaccurate, whatever documentation types, or you want to see some new feature or some new hardware supported, please propose features or use cases that, we haven't covered. And through that process, the system will get richer because this project is all about open governance. It's a project for the people, by the people, that sort of stuff. So you can join any work group. If your passion is security, please come and enhance the security of OPEA. You can join the technical steering committee. We have a few members, but everybody is welcome to come and influence this project. So with that, I have two links at the bottom, the upcoming community events, and you're welcome to propose new ones. We have a Slack channel, and then we have the OPEA GitHub repo itself. So with that, thank you. And I don't know how it works if we have questions or whatever, but
Thank you very much, Malini, for your great presentation. Thank you. We're running a bit behind schedule, so maybe a couple quick questions. Does anybody have a question? There. Thank you, Ben.
Thank you for the talk. There are a couple of projects already at the Linux Foundation that are already discussing this kind of open government, governance, health, and many other aspects. It seems the open platform is working in silos. I don't know which measures we could put together to build a more inclusive platform where it will have better representative. For example, you mentioned things that I also realized that ML Commons is doing. You mentioned things that the Linux Foundation, the Health Project is doing, Kiosk, and many others. Thank you.
Malini's muted.
Sorry, sir. Excellent question. The Linux Foundation, in its inclusivity, doesn't always see if there's overlap and promoting and helping things to work together. So exactly like you said, there's another project called Trusty AI, and that was launched by Red Hat. And I said, hey, wait a minute. We don't need to redo some of this. We'll just use Trusty AI stuff in our evaluation. And that's part of our security work group thing, to bring them in. And we've had some talks with them already. So that's one. With healthcare, we haven't yet looked, Ben, and we'll look. But right now, we just have very basic stuff. We don't have any medical expertise in our team. We do need partners in that space, so it would be very good to bring them together with us, see if we can leverage some of the things together. If theirs is all healthcare specific, then maybe we bring in the enterprise readiness piece with all the auth Z, auth N, that sort of stuff. So I'll take a look at that. And feel free to send me email, and then we'll connect, and let's see how we can work together to bring these projects closer and sing together as opposed to, beside each other. But thank you for that.
Okay, let's thank Malini for the presentation. Thanks so much. Please reach out to her if you have additional questions. Thank you. Thank you.